Daikin is the first to develop and launch the VRV air conditioning system, world's first use of variable refrigerant flow control in 1982. Since then, Daikin VRV has been widely used and installed worldwide. Daikin provides installation training as to meet with the increased demand for installation works and installers. This video is a guide to the installation of Daikin VRV air conditioning system. This video will explain the procedures of unit installation, testing and maintenance. Make sure installation work is conducted as per instructions in the installation guide. Planning. The installation of VRV air conditioning system begins with planning to define the details and classification of work as well as to create installation design. The design created by engineers and consultants serve as a guide during installation. This initial process continues with procurement and transportation of goods. As a Daikin VRV installer, it is important to check the installation tools, which includes flaring tool, flare size gauge, pipe expander, pipe cutter, pipe bender, hand drill, torque wrench, R4 10A manifold gauge, brazing tool, copper pipe, PVC pipes for drainage, brackets and rods, air conditioning projects drawing, pipe schematic, and personal protective equipment. Transportation. Indoor and outdoor units are transported to the installation location in original packaging. Do not remove the original packaging before installation. Upon receiving the product, make sure that the indoor and outdoor units are in good condition and supplemented with relevant accessories and manuals inside the package. Installation procedure for indoor and outdoor units may vary between models. As such, study the instructions in the installation guide first. Installation of indoor unit. Personnel should be equipped with complete installation tool and PPE. Follow the piping routine and indoor unit layout plan. Provide adequate clearance for service and installation space. Using a drill, make holes on the mount points. Determine the length of mounting bolts in accordance with the desired installation height. Before installing the mounting bolts, place the nuts and washers on their respective mounting bolts. After installing the mounting bolts, adjust the bolts on the lower part to fit the installation height. Secure the bracket with washers and nuts. The height of the indoor unit can be adjusted by loosening the two nuts that secure the rod. If the mounting bolt is longer than 1.5 meters, additional support is required. After all mounting bolts are installed securely, install the indoor unit. Hook the main mounting brackets of the unit to the hanging rods. Secure with double nuts. After installation of the indoor unit, check and make sure that the unit is level. Cover it with plastic bag or something similar to protect unit from debris and dust. Piping support. The first step to work on piping support is to specify the location and distance between supports. The ideal distance between supports for horizontal refrigerant piping is 1 to 2 meters, depending on the diameter of the refrigerant pipe. As for vertical refrigerant piping, the maximum distance between supports is 1.5 meters. If liquid and gas refrigerant pipes are installed together, adjust the size of supports in accordance to the size of the pipes. Prior to supporting the refrigerant pipe, install PVC protective pipe around the insulation material at the points where the supports are to be installed. This is to prevent the insulation material from tearing due to the weight of the pipe. For horizontal drainage pipe, the ideal distance between supports is 1 to 1.5 meters. The length of drainage pipe needs to be calculated so that the pipe is in a declining gradient, with a 1 centimeter decline per 1 meter of the pipe length. If multiple pipes are installed in parallel assembly, provide adequate space for maintenance. Refrigerant and drainage pipe supports also need to be installed on branching and turning pipe around the indoor unit, as well as on pipes that go through walls. Installation of refrigerant pipe. The basic principle of installing refrigerant pipe is that the pipe should be clean, dry and tight. When storing refrigerant pipe, make sure that both ends of the pipe are covered. Do not place pipes directly on the floor. Use a table or shelf to store the pipes. Pipe ends can be covered using duct tape. However, when pipes are to be stored for more than 1 month, the pipe ends should be welded shut. Refrigerant pipe protection, either for storage or during installation work, is intended to prevent water, debris and dust from entering the pipe. Otherwise, the performance of the air conditioning equipment may be compromised and thus lead to machine malfunction. For cooling system, use insulation materials that can withstand temperature more than 30 degrees Celsius with adequate thickness. For heat pump system, use insulation materials that can withstand temperature of more than 70 degrees Celsius with adequate thickness. Insulate liquid and gas refrigerant pipes separately. Do not use damaged or torn insulator. To cut off pipe, use the copper pipe cutter. Turn the pipe down to prevent the copper debris from entering the inside part of the pipe. Rotate the pipe cutter blade bit by bit. Then, smooth the cut parts using deburring tool. To bend refrigerant pipe, one of the tools you can use is lever-type bender. First, mark the part of the pipe to be bent. Align the end of the tool arm with the O marking on the clamp. Align the mark created on the pipe with the R or L mark on the tool arm. Move the arm to bend the pipe to the desired angle. Bend the pipe slowly to prevent folding or defect on the inside of the pipe curve. Do not bend pipe to more than 90 degrees. To connect two refrigerant pipes, expand the end of either pipe using pipe expander. Insert the expander into the pipe and slowly move the lever. After connecting the two pipes, the next step is to weld the pipe joint. Flow nitrogen through the pipe to prevent oxide fill from forming inside the pipe during welding. The nitrogen should be of purity level of minimum 99.99%. Prior to flowing nitrogen, cover the other end of the pipe using duct tape with small hole to allow the nitrogen to flow out. Switch on nitrogen gas regulator to 0.02 megapascal. Ensure the pressure of nitrogen is not too high, as it may cause inadequate attachment of weld filler gas on the pipe joint and may lead to holes on the pipe. Before welding, ensure that the pipes have been connected properly, with the end of the expanded pipe supporting the attached pipe in horizontal position properly without falling. Required tools for welding include acetylene tube and regulator with double-hose flashback protection, oxygen and regulator, solder and other welding equipment. Heat the surface parts of the pipe that will be connected and the nearby area evenly until the pipe surface turns bright red and reaches 640 to 780 degrees Celsius. During welding work, wear protection gear such as safety goggles and gloves. In addition, prepare fire extinguisher. Create a distance of 3 mm clearance between the carburizing fire end and the pipe with an ignition angle of 80 to 85 degrees. Carburizing fire end should not touch the pipe. Melt filler metal gradually, then slowly attach onto the pipe joint. Filler metal soldering on pipe should be in overlays to prevent leakage. When the process is completed, cool down the soldered pipe using wet cloth. Do not turn off the nitrogen until the pipe cools down completely. To connect branching refrigerant pipe or ref net to the main pipe, use straight pipe of at least 0.5 meter length. The ref net position should be horizontal, not vertical. The distance between a pair of ref net should be further than 1 meter. Use insulator and adhesive to insulate the ref net. Using dedicated adhesive, seal the pieces of pipe insulation material attached on the piping supports. Layer with tape from top to bottom. To facilitate easier installation, use the prefabricated ref net. Indoor pressure test. After all refrigeration components have been connected, check for leakages by performing a pressure test. To allow easier identification of leakage, perform pressure tests to all pipes during piping installation. Apply pressure onto liquid and gas pipe by flowing nitrogen from 0.3 megapascal to 1.5 megapascal to detect large leakage, followed by 4 megapascal to detect small leakage. Perform the test for 3 to 5 minutes to detect large leakage. If there is no decrease in pressure, continue the test for 24 hours to detect small leakage. If the pressure decreases, find the location of leakage using soap water on the surface of pipe joints and replace any leaking pipe connection. Decrease of pressure can be tolerated when room temperature drops, which is by 0.01 megapascal per 1 degree Celsius. After completing the leakage test for refrigerant piping, connect the pipe to the indoor unit. Apply refrigerant oil onto the surface of the pipe to connect. Tighten the connection nut using your hand. Make sure you use the connection nuts provided with the indoor unit. Fasten the nuts using torque wrench. Do not turn the nuts too tight as it may damage the joints. Installation of drainage pipe. Drainage pipe installation begins with pipe work on the side of the indoor unit. Flexible pipe should be installed on the indoor unit before being connected to PVC pipe using connector clamp provided with the unit. Do not use adhesive to connect drainage pipe and indoor unit as it will restrict service and maintenance work. To improve water flow, make sure that the drainage pipe is installed tilted with a 1:100 ratio. The length of drainage pipe to the final water depletion location should be made as short as possible to prevent formation of air gaps. Do not connect drainage pipe with building's exhaust or waste channel as it may cause unpleasant odor. Minimize the number of connected units to prevent excessive length of drainage pipe. Install a pipe plug onto the top of the main channel to test the water flow. Perform water flow test by filling water through the plug. If no problem arises and water flows properly, attach insulator onto the plug. Installation of control cable. This is a power cable, and this is a control cable for communication between indoor and outdoor unit. Use 2-core compatible control cable protected with vinyl sleeve, with specification of 0.75 mm square to 1.25 mm square. Control cable and power cable installed in parallel assembly should be separated with a clearance of minimum 5 cm to prevent interventions. Do not use multi-core cable, as it may cause signal interference and transmission errors. Each indoor unit should have an individual single-phase supply. Installation of outdoor unit. Transport the outdoor unit to the installation location in upright position to prevent damage to the compressor. To lift or hoist the outdoor unit, use proper tools and refer to the installation guide to prevent damage to the unit. The height of outdoor unit support should be a minimum of 15 cm from the floor surface. Install unit to the foundation using Type M12 nuts, bolts, rubber dampers and washers. The height of nuts from the foundation surface should be a maximum of 2 cm. When installing rooftop outdoor unit, make sure that the roof floor surface is waterproofed. Provide clearance between piping line and outdoor unit for service and maintenance work. Ensure that the suction of the outdoor unit has good ventilation. This is to prevent short cycling of hot airflow. After completion of all refrigerant pipe works, perform vacuuming test, then remove so that the pipes are empty and in clean condition for pressure test. During this phase, install gauge on the service ports of the liquid and gas refrigerants. Choose vacuum pump that can produce up to minus 100.7 kPa pressure and can increase release volume. Turn on vacuum pump to minus 100.7 kPa. Turn off vacuum pump and leave the pipes in vacuum state for 1 hour. This is to ensure that gauge indicator does not rise. Testing and commissioning. The following is the process for testing and commissioning. Prepare the required tools. Calculate refrigerant addition. Measure the length of refrigerant pipes to calculate the required amount of refrigerant. Always use R410A refrigerant. Use a digital scale. Connect the manifold gauge onto the gas and liquid stop valves. Set refrigerant filling to on. Position the tank face down so that refrigerant is filled in liquid form. When refrigerant filling reaches the desired weight, close the liquid valve. Write down the calculation of refrigerant addition on the refrigerant addition instruction label attached in the outdoor unit. The data will be required during maintenance. Check incoming power supply using multimeter. Check the number of connected indoor units on the outdoor unit PCB. The number will appear on the digital display. Press and hold BS2 button for 5 seconds on the outdoor unit PCB to conduct test operation. On the digital display, T01 code will appear. During test operation, outdoor unit will be operating. All connected indoor units within the outdoor system will be turned on automatically during test operation. In the event of abnormality, test operation will stop automatically. Error code will be displayed. Troubleshooting is required. After test operation is completed, write down the results and hand over the copy to customer. Maintenance. To ensure optimal performance of the unit, perform a set of periodic maintenance and check. Prepare the required tools for maintenance, such as multimeter, clamp meter, airflow meter, digital thermometer, and manifold gauge. Clean the air filter of the indoor unit regularly. Remove the filter and clean using vacuum cleaner. Or spray using jet cleaner in vertical and horizontal direction to remove dust and debris. Do not use hot water of above 50 degrees Celsius. Clogged air filter will cause a reduction in the airflow rate. Ensure that the air filter is completely dry before fixing it back. Straighten any dented condenser fin using fin comb. This process aims to straighten the condenser so that the air can flow smoothly and attached debris can be removed easily. After straightening the condenser fins, wash the fins with clean water. Install the manifold gauge on the service port on the outdoor unit to check the operating pressure during servicing. During stable running condition, suction pressure should range between 0.65 megapascal to 1 megapascal. Discharge pressure should range between 2.6 megapascal to 3.2 megapascal, depending on the ambient temperature. Check running current using clamp meter. Check incoming power supply, voltage using multimeter. Ensure that the air filter, fan, blower and condenser are in clean condition. Insufficient or excessive refrigerant will affect system performance and might damage the compressor. Turn on indoor unit using remote controller. Check air conditioner performance after maintenance. Write down all maintenance and repair actions taken and schedule the next maintenance. Regular check and maintenance of indoor and outdoor unit may upkeep the system performance and maintain the product lifespan.